to misinterpret the word area. Alright? So we'll just call it the space between the curve and the x-axis. Cool? Because sometimes we can have a space between the curve and the x-axis that's below the axis. So that's like a negative area. Can we have negative area? Oh. It's a really easy lesson. It's very similar to what we've been doing. The only difference now is the way that it's presented, the way that it's asked. You need to interpret what it is or how to approximate that definite integral. So we worked a little bit at the beginning with integration and antiderivatives. And those integrals that we were working with were called indefinite integrals. Okay, that's why we had an infinite number of solutions to that antiderivative, right? That's why we had to put the plus what? The plus C on all the answers, right? Okay. What we're going to work with today are what we call definite integrals. So notice that they have limits. They're going from a certain number to a certain number. Do you see that? Okay. And the result of that, it says, is a value that represents the area of the region bounded by the curve of f of x and the x-axis on that particular interval. Now this word here, area, is kind of misleading. Okay, so I don't want you to think of area as the way we normally think of area in geometry, but I want you to think of it as the space
What?
Okay, I want you to think about it as the space between the curve and the x-axis from A to B. Okay, the reason I want you to think of it like that is because you're going to have parts of the graph that are below the x-axis, and those are going to actually give you negative answers to this particular problem. So then some of you might start thinking, well, if it's supposed to represent the area, how is it that I'm getting a negative number? You understand? So we know from geometry that area should not be negative. So it is the area, but it's a little misleading the way we think of it. Yes? Sounds good? Let me show you an example. Let's say I have this graph here. Okay. And the graph goes up like this and then comes back down like this. And I ask you to approximate the integral from 3 to 5. We're going to call this f of x. I want to know the integral from 3 to 5. What do you think the result of that is going to be? It's going to be some negative number. Why is it going to be a negative number? This space right here is where? Where's that space? Beneath the x-axis, right? So it's going to give me some negative number. Can we have negative area? No. Okay? Do you understand? Yes? What if I asked you to find the integral from 0 to 5? What do you think the answer would be? 0? Why 0? Because they cancel each other out, right? We find the space bounded here and the space bounded here. One of them's positive, the other one's negative, so they cancel each other out. So we're saying that the area is 0? A little misleading, right? Okay. Most of the times with these problems, we'll be asking you to find the integral of, or the area under the curve of, will be like a velocity graph, right? So what does the velocity graph represent? In this class, when we're talking about like particle motion, because that's all that will be presented on the AP. Velocity is describing the direction that the particle is moving and the rate at which it's moving at, right? Okay, so if this were a velocity graph, what would be happening here? What is the particle doing? Moving to the right because velocity is positive. Then it does what here? stops and changes direction and now moves to the left, right? So if we said that the integral from here to here was 0, what does that mean? Displacement is 0? Oh, okay, so whenever we integrate a function normally like that, what we're finding is the displacement, right? The net distance. The distance from where he started to where he ended. So if that's 0, that means he moved to the right a certain distance and then moved that same distance, what? To the left and got back to where he started. You understand? Yes? Sort of, kind of? How would I find the total distance? Do one part and the other part? How can I make this positive so that way I can find the total distance? Yeah, so I could actually get the absolute value of this f function, and that'll make everything in that function become what? Positive, so it'll make this part flip up, right? And then it'll look like an M, or something else, right? And then we could find that area, or that space bounded between the curve and the axis, and that space would be all positive, right? Cool? Alright. We're not going to get into finding integrals of absolute value functions, okay? But we will talk about that later when we start correlating this to that, the particle motion. Kind of getting ahead of myself here. Sounds good? Do we understand why I don't want to specifically say the word area, but rather the space? Yes? So understand that you could get negative answers, okay? When you evaluate an integral, your answers can be negative. Right? Now notice what's the difference between this one and this one down here. So the bottom one says equals and the top one says what? Approximately. Okay, what's the difference on these Riemann sums over here? So this one has a limit. Why are they putting this limit here? What is it representing? Infinite number of rectangles or subintervals, right? So I want to make an infinite number of subintervals, and if I do that, I'll make the interval so small that it'll make it to where I can fit all the rectangles or all the trapezoids perfectly underneath the curve and find that exact area. Do you understand? So the integral actually will give us the exact area under the curve. Yeah? So since we already kind of know how to integrate, we're going to use that tomorrow with the first fundamental theorem of calculus, and we're actually going to start calculating areas under the curve, the exact areas, rather than approximations like we've been doing so far, using the Riemann sums. Okay? The only thing I wanted to do today was to show you that the Riemann sum approximations, okay, are approximates of this particular definite integral from a to b. Because you got to get used to the notation. Because there'll be problems like this problem right here where it says approximate this using a midpoint sum. Okay, so you need to know, bless you, that we're going from 0 to 25 in my interval, and I'm going to use some Riemann sum, okay? Now it doesn't matter which one you use up here, they would both work out, right? But down here, they're going to ask you for specific ones. Do we understand? So here, I put it generic, I just put f of xi times delta x, and this would be using whichever of the four Riemann sums. It doesn't matter which one you use there, okay? This one will always be an approximation. This one with the limit will be the exact answer. Got it? The reason I'm showing you that is because there's problems on the AP test, on the multiple choice, where they'll give you a problem written in this form, and they'll ask, okay, which of the following answer choices is equivalent to this? So you need to know that it's the same thing as that definite integral from A to B. We understand? Yeah? Alright. Ready to jump in and do some examples? You're not gonna freak out? So basically the same thing, right? Except now that I'm changing the way I'm asking it. Alright, so now I'm saying approximate this integral from 0 to 25. Be very careful on your answers now. You're not gonna put equals, you're gonna put what? Approximation symbols, and you're going to use this notation here. We're not gonna say A of 5. We're not finding the area of 5 rectangles anymore. We're finding this integral. Got it? What's the interval that we're gonna use here in this first one? 0 to 25. Are they equal subintervals? Are they just random 3 subintervals? You have to check. Pretty random, right? They didn't say to make it 3 equal subintervals. They just said 3 subintervals, right? Using which sum? Okay. I need to create 3 rectangles, right? I don't care the subintervals, I just need 3 of them. So what would be a good way of making those 3? Going from where to where? From 0 to 7? 7 to what? 15? 15 to 25? Did I make 3? Yeah. Could I have made it differently? I could have made it differently, right? What's the width of the first one? 7. What's the width of the next one? 8. And the last one? Now, if they asked us to use a midpoint, what would I have to use for the first one? What's in between 0 and 7? 3.5, but is 3.5 on my table? No. So I have to use the next best thing, which is what? 4 and 6. Do you understand? Between 7 and 15, do I have the exact midpoint? No. But I'm going to have to use something that's in between them. And between 15 and 25? It's perfect?
Yeah, that one's easy.
Alright. Do you understand? You're going to have to work with what they're giving you, okay? And apply what you're trying to do. I can't use 3.5 exactly because I don't know what it is and I can't figure it out. We good?
Yeah.
Alright, so let's set it up here. We're going to write the notation, the integral from 0 to 25 of that function is going to be approximately, how do I find the area using the midpoint? You remember we're doing rectangles, right? So rectangles is height times width, right? Or width times height, whatever you want to do. So what's the first width? 7, and what's the first height? 6, because we're using the midpoint, right? If we were using left, we would use what? 15. If we're using right, we would use -5. Do we understand? Doing the same thing we did last week. Plus, what's the next base? 8 times -10. Plus, what's the next one? 10 times 8. Alright. So this integral is approximately what? 42 minus 80 plus 80, right? So 42. So what does that mean? There was more space where? Above the x-axis in comparison to? Below the x-axis, right? That's why on average my answer was positive. Or we could say that the particle was moving more to the what? To the right than it was moving to the left, since my answer here is positive. Got it? Part B. Where are we going from on this one? 0 to 15 only, okay? So we got to pay attention to that definite integral. So what can we scratch out from my table here so I don't get confused?
20 and 25.
20 and 25, scratch them out so we're not even looking at those. And we're doing what kind of a Riemann sum?
Left hand,
Left hand, and how many intervals?
4.
4. So how can I make the 4 intervals here? Zero to 4, 4 to 7, 7 to 12, 12 to 15. Do we make 4?
Yeah.
Awesome, okay. Find the widths. What's the width of the first one?
4,
4,
3,
3,
5,
5,
3.
3. Alright, we're ready to go. Now we're using the left-handed endpoints. So between these first two, which one's on the left?
15.
15. And then, between these two?
6.
6. And then between these two?
-5.
And then between these two?
-10.
We're using those that I circled, okay? Let's do it. So we say 4 times what?
15.
Plus 3 times?
-6.
6. Plus 5 times?
-5.
Plus 3 times?
-7.
Good? 4 times 15, that's what?
60.
60 plus 18
-15.
minus 25
-30.
minus 30.
Only 3. I rolled a 3.
So what would be my approximation for this definite? He's a very famous basketball player, won this. They say he's the greatest one that ever lived. 23?
Cool.
Maybe in his time, right?
Cool.
Anybody know whose basketball jersey number that? Jordan? You're good, man. You weren't even born when he was around, right? Two more examples and we'll be done, okay? This one's saying to go from where to where?
We changed two on.
From 4 to 20. Probably not a good combination to use there. But anyway, what can we scratch out here?
Yeah,